Hello everyone and welcome to ML Done. So this is the first video of deriving mathematical stuff in machine learning, mathematical equations, mathematical relationship. And for the first video of these video series, I've decided to actually derive the partial derivative of the sigmoid function with respect to its input. So if you think about it, this is our sigmoid function. That's how we show that. Right? Sigmoid of x equals 1 over 1 plus e to the power minus x. And we know that, if you just search it, we know that the partial derivative of sigmoid of x with respect to x is, that's how we show it, is equal to the sigmoid of x itself multiplied by 1 minus sigmoid of x, which is pretty neat actually. So the partial, the derivative of a function with respect to its parameter x is actually the function itself multiplied by 1 minus the function itself, which is very cool. So today we're gonna prove this to you and go through it step by step. Okay, so this is a fraction, right? So if I want to take the derivative of my sigmoid x with respect to x, I can use the calculus rule of taking derivative of a fraction with respect to its input x, to its parameter. So it is a fraction, right? So the partial derivative of this thing with respect to x, we know from calculus that if you have a function, I'm just going to have a side note over here. Let's say I have a function h of x that is equal to, say, f of x divided by g of x, right? So in order to take the derivative of h of x with respect to x, the rule says the derivative of f multiplied by g minus the derivative of g multiplied by f divided by g squared. So f prime of x, gx, minus g prime x, f of x, divided by gx squared, right? So if I want to show you a very simple example, let's say h of x is equal to, let's say, x2 divided by 2x. Let's say 2x minus 1. So the derivative of h of x with respect to x would be the derivative of the denominator with respect to x, which would be 2x, multiplied by the denominator, which is 2x minus 1, minus the derivative of the denominator, which would be 2x minus 1 with respect to x. If you take the derivative, minus 1 is a constant, so you just end up with the coefficient 2 multiplied by the denominator, which is x2, divided by the entire denominator squared. Okay? Perfect. So that is what we have to do here. Right? Again, we have a fraction, but it's a very simpler case because our denominator is a constant, so it's not a function of x, actually. So the derivative of that with respect to x is actually 0. So we don't even have to worry about that part. So, long story short, that's the path that we're going to go. But one more thing that I need to emphasize, another rule. Because we have an exponential function here, I think it's a good idea to actually remind you of a little rule here, right? So if you have e to the power, say, u, where u is a function of x, okay? And if you're asked to compute the partial derivative of e to the power u, not with respect to u, but with respect to x, so u is actually u of x, that's more accurate. With respect to x, that is equal to, so we know this from calculus, the partial derivative of u with respect to x, so that would be u prime x, multiplied by the entire thing as it is, e to the power u of x. We don't even need this much space. Let's keep it small. Yeah? So that is our rule here. Yeah? I'm going to use that. So, back to our sigmoid. I'm going to take the derivative of this guy with respect to x. So the partial derivative of the nominator with respect to x is 0. Multiplied by the entire denominator, we just cancel it, zeroed out, right? Minus, according to our rule, the partial derivative of the denominator, which is 1 plus e to the power minus x, with respect to x, multiplied by the nominator, which is 1. So I'm not even gonna write it down. You don't need to, because that will be the expression itself. Divided by 1 plus e minus x squared. Right? Now, how are we going to do this? The partial derivative of 1 plus e to the power minus x with respect to x. That's very simple, isn't it? I mean, if you think about it like this, remember, this is not a division. This is just a partial derivative of this expression with respect to x. And then the entire thing will be divided by this. Right? So, if you think about it, the partial derivative of 1 plus e to the power minus x with respect to x would be equal to, so 1 is a constant, the derivative of that with respect to anything is 0. So the only term that we have to be concerned with is e to the power minus x, right? So the derivative of that with respect to x, you see, according to our rule, the power is a function of x. It's minus x, right? So according to our rule, we first have to take the derivative of that power, which is minus x, with respect to x. So derivative of minus x with respect to x is minus 1. So the coefficient survives. Minus 1 multiplied by the entire thing, e to the power u of x, which is e to the power minus x. So minus e to the power minus x is the answer to this whole thing, right? So we have, again, don't forget about the minus, that's very important. We have a minus here already. So this expression is equal to minus e to the power minus x divided by 1 plus e to the power minus x squared. Right? So let's get rid of all of these. Don't need any of this. Perfect. So minus by minus would be plus, so I'm going to get rid of that part as well. This will turn into a plus. Now, take a look at here. This is actually very interesting. You can actually expand this, right? So you can say it is equal to e to the power minus x divided by 1 plus e to the power minus x multiplied by, because it's square, again it's self, right? 1 plus power minus x. Now, there's something very interesting going on here. Because if you think about it, the nominator is actually, you can think of it as 1 multiplied by e to the power minus x, right? So you already have the sigmoid element here. If you think about it, there's 1 here, 1 multiplied by this whole thing, right? So this part is already your sigmoid, isn't it? Right? So you can write this whole expression as sigmoid of x multiplied by this expression, e to the power minus x, 1 plus e to the power minus x, right? Now, we're gonna play a little game here. I'm gonna add, so remember, the first bit has been proven, sigmoid of x. So from this part, we have to sort of extract 1 minus sigmoid of x. In order to do that, we're going to add 1 and then subtract 1 from the denominator. That's the game that we're going to play. So we're going to have, we're going to have 1, and then we're going to extract 1. What's going to happen? Can you see it? It's actually very interesting. This expression, this part, what is it? You can say this divided by that is 1, right? This part is 1. So if you think about it, if I keep writing sigmoid of x, we've already computed that, multiplied by, let me just open a big squared bracket. This thing, so this part of the denominator divided by the denominator, which is 1, minus 1 over, again, the denominator, minus 1 over the denominator, 1 plus e to the power minus x. And what is this? This is again sigmoid of x, isn't it? So basically you have the partial derivative of the sigmoid with respect to x is equal to the sigmoid itself multiplied by 1 minus sigmoid itself. So we proved that, okay? So that is the entire thing. So the main trick was adding 1 and subtracting 1 from the denominator. So if I want to do this one more time fast, okay? Because we talked a lot, we had to remind ourselves of everything. If I want to do it fast so that it would make sense faster, I'm just going to do it one more time, but this time without, digressing into other calculus stuff. So the partial derivative of sigmoid of x with respect to x. 0, the partial derivative of the denominator multiplied by the entire denominator would be 0 multiplied by this, which is cancel out, minus the partial derivative of this guy, which is with respect to x, which is 0, that would be minus e to the power minus x divided by the denominator squared, which is 1 plus e to the power minus x. Again, 1 plus e to the power minus x, right? And we said that minus minus would cancel out, so I don't even need this part. And then we said that we could write this as 1 over 1 plus e to the power minus x, right? And then we said that the other part, we could say that. We could say 1 plus e to the power minus x minus 1. Again, 1 plus e to the power minus x. And then we said that it is equal to, this part is my sigmoid, and this part, this section, can be divided in 2 separate roots. So I have sigmoid of x multiplied by, this part would be 1 minus 1 over this expression, which is again sigmoid of x. So this was our partial derivative. And this is our proof. So I hope that this has been informative for you. We're going to do more and more of these derivations, especially the ones that are problematic. One of the ones that we always used to struggle with was actually the softmax. We're going to do that as well in the future. So feel free to subscribe to the YouTube channel. You can follow us on Twitter, LinkedIn, Facebook, and also check our website, mldone.com, where we have very interesting posts and also very interesting courses. So feel free to post the questions that you might have in the comments section. And yeah, I hope that this has been informative for you, and thanks a lot for watching. Bye.